Am I live? uh, uh, Wait a second. Start TTS. Here we go. Hello everyone. That's an unannounced stream. Or at least like only 5 minutes announced or something. So, I couldn't schedule this stream for one reason. I was coming from Berlin with the train with the €9 ticket, which is basically the slow trains. And it took, so I should have arrived at 5:30 and I arrived 7:30. I was 10 hours on the road today. So I'm really exhausted. There is no specific topic today. So hello Tech, hello M40K, hello Sniff on Taurus, and that's all. All the people. Why? Oh no, I can't hear anything. Oh, there is the bitluni. It's okay. No, not prepared. I yeah. Pink LED project. No. So wow. Oh, all of the sudden everyone appeared. Hello Arduino Zone. Hello Fruchti. Hello Johnny M40K. Oh, M40K was there before. Hello Jordi. Hello Swift. Hello Hafkenside. Wow. Option 22. Yes, I reset it. Textman. Okay, so I was on a concert yesterday, Aurora. It was really cool. Great artist. And yeah, that's why I took the train for €9 to Berlin. 10 hours in one direction and 10 hours back. And since I didn't book a hotel early enough, everything. What? Which tweet? Oh. Oh, really? Which one? Tell me about it. So, I really. Let me check that. Nice. Oh, what? No Klaus? Nah, no Klaus Schulze. But I like enchanting voices, and Aurora basically is that. Like Aurora, like Fever Ray, and so forth. Like all these female singer-songwriters, artists are really great. And it was really cool. Okay, so I didn't book a hotel early enough. And it was basically everything is booked out in Berlin. I don't know what happens there, but you can't get a cheap room in Berlin right now. So a night costs around maybe 100 euros or something. That's expensive for me, since that would be like 2 weeks of YouTube income for So I took a tent with me. I took like a backpack this size with sleeping bag. Okay, so I took a tent, sleeping bag, and few clothes and stuff with me, my tablet, and yeah, I was sleeping in a tent. But I didn't. Yes, yes, but we have. Yeah, I'm totally wasted. Okay. Basically, what I didn't expect that it's 11 degree in the night. So I was waking up at the night and freezing. So it was really too cold for at least this sleeping bag that I took with me. I have some better outdoor gear, but I didn't have even like pants that were long. So I had like only these pants with me. Oh. Frostloon, yeah, that is basically it. So it was a journey. Yeah, tomorrow is house visit, but I already have some worrying facts about the house. So it's a bummer, but I'm we currently unless like the inspector tells us, yeah, this is a great house, buy it. Yeah, it might be like it might be like too much formaldehyde or something. So it's like a wood framed house, and at that year where this was built, there are like better regulations for that, but I don't know if we feel comfortable with that. So we will check tomorrow with the inspector. We have I'm really like I was really down yesterday when I got that information, and we will see tomorrow how it is. Maybe we will do like an extra room air analysis. I don't know how it is called in English. Yeah, wood frame. Yeah, yeah, but they used like in the 60s, 70s and early 80s they used like really toxic wood like so it's not like only drywall. You have like the studs, and then you have like this, what is this? This Spanplatte. I don't know. It's not plywood. Some sort of that. Oh yeah, Laura, I didn't watch the last video on that. She found even something else there. I love watching her videos, but I didn't have the opportunity to. So don't spoil what she found in the basement. Yeah, particle board basically. Yes, yes, yes. Yeah, and they are basically glued with all of the toxins which were discovered to be like cancerous, and um, what happens there, they evaporate all the toxic stuff into the room air, and I don't know if I feel comfortable living in such a house, um, especially what worries me the most, if we ever want to flip it, like, so I would like rebuild it and do everything great with that and improve it. Banks wouldn't fund this house. So whenever we want to sell it for like, let's say 300,000 euros, then someone who would be interested in buying that house, no matter like uh, if he knows everything about that house, because we have to disclose everything. Transparent border, that's basically my monitor. Let me put it in. Yeah. So So the problem is not that somebody wouldn't like to buy it if I'm finished with that. Oh no! Oh, spoiler! Stop it! Don't spoil. Yeah, so the problem is the bank wouldn't grant a loan to a house that's like from the 80s. They have like a lifespan of 60 years. So expected lifespan is like 60 years for these houses. And even though it wouldn't be like toxic, like with a measurement, they require to give a loan, they require the measurement of the air. And if it's good, they still won't give you a huge loan because the lifespan or expectancy of that house, like wooden frame house, would be like 60 years and it's already 35 years old. So basically, we would either live there forever, but I don't think we want to do this. And then if we want to sell it in 10 years, it would be like remaining lifespan of 15 years. No, yeah. Remaining lifespan of 15 years, nobody would buy that with a loan. Yeah, yeah. Yeah, so yeah, not homegrown. Yeah, they all like my cherries were basically died. We had some frost, unexpected frost, and my cherries died. And that's bought stuff. Yeah, cherries, and we don't grow. I tried to grow strawberries, but we don't have any. Okay, so this is the update from the house. I'm really bummed, and I really wanted to live there because there's a nice lake close by. I even took a sponsorship for stand-up paddle boats. They arrived already, so we're going tomorrow there, and I will try to get some footage for a project where I want to. Okay, so I spoil you now. Where's the stuff? I prepared the stuff somewhere. My lab is a mess. I didn't have time to. Yeah, this is something that we will unbox. Okay, here are lithium ferrite phosphate ferrum phosphate batteries. Oh yeah, here. Then we have a water-cooled in-runner motor, a water-cooled speed controller. I bought this stuff like years ago. Okay, so a water pump and yeah, some other stuff. Yeah, lithium iron phosphate. Yeah. That's what I wanted to say. So basically, I charged them already up. So what we could try, but I want really to film this really nice because it's a sponsored video and I want to be nice. What I want to do is like a propulsion system, a backboard motor that you can. Oh wow! Yeah, and I want just a electric motor like that you can attach to the stand-up paddle boat, to the stand-up what sub. It's called sub basically. Yeah, and I want to attach it. I get a cut. I didn't get paid for that, but I got the boats and I get affiliation and I have a coupon code, bitluni coupon code for that. So I'm looking forward to that project. I need to release it quite soon because we have good weather now and summer is like the season for this sports, and I can attach the motor there. But first of all, we want to open this up. I don't know what this is. It's from China. Let me hook up the camera. So we can unbox something that I received from, I hope it's from China. And we can, oh, foo. Yeah, and this week's project, oh yeah, great, thank you for buying this stuff. Okay, here, battery empty. Okay, let me switch battery. Oh, no, battery isn't. Nah. Yeah, everyone's favorite. Here we go. Okay. Oop. Boop. Here we go. Now you can see all the trash underneath my. Okay, so let's open it up and we test. I have a clue what this could be. Okay, so what is it? Any guesses? Any guesses what this could be? Ooh. Hello! Oh, my face! Hello! It's me, the bitluni. Hey, Brian. Hello, kids. Yeah, I hope I didn't get COVID in Berlin, but it should be good by then. Okay, yeah. What is it? Okay. So any guesses? No, I forget it every time. Brian, you are mean. You are mean. I forget it every time. I will practice. Hoverboard motor. It's not hoverboard motor. It's not LEDs. Okay, I will open it slowly. Okay, let's do it ASMR. I will attach my microphone to it. To the knife, like that. What? No, no way, no way. No, I had enough embarrassments this week already. No. Metal extract. No, it's not. What is? Okay. Yeah, that's really. It's bubble wrap. I will unwrap it. Here we go. There is more tape. Let me cut this open. So, what is it? It's not resin. No. It's not a pasta machine. It is some kind of motor. Oh, this thing is huge. Mounting brackets. Okay. Oh yeah, look at this. My finger is recovering. Okay, let me enter SMR. Okay, here. Yeah. So I lost some skin there. And yeah, I don't know if my fingerprint will probably not recover 100%, but it's looking good. And thumb should be, oh, I don't even see it there. Oh yeah, here. So there is still yeah, a little bit. So that one, what is this? I knew I've seen it. Okay. So it's a specific one. It's 30 millimeters per second, so it's a little bit faster. Yeah. Good luck with that. I change it every week. Yeah, really? Okay. Okay, so it's 12 volts. Let's try it. Do we have 12 volts? This is 14. It's too much. This is 18. This is 14. Yeah, 14 should be... No. I don't want to destroy it because it took a little bit to arrive. This is 11. Okay, that's good. Okay, so we have LiPo here. Is it even? I have no clue if that works. Okay. This way. What is this length? No. Okay. Yeah. It's not greenhouse. This is 300 newtons, so this should be able to push 30 kilos. Okay, let me check. Yeah, that's 20 centimeters. Erection is. Okay, let me check if it's strong. Oh, okay. That could be 300 Newton. You know what? If you look on AliExpress, if you look for linear actuators, there is a point where you get suggested such actuators that you are talking about. And there are like specific ones, like with suction cups, for suction cups and special properties. And then you need to read the reviews of that. Yeah, it should be. I bought Metal Gear thingies. No. So this will be the steering for my car. My car that uses these things here. And I need to, I need to have some proper steering on that. Okay, so, by the way, I don't want to stream for too long today, like only 2 hours, because I have to prepare stuff for tomorrow. But we will still have some fun. Okay, what did I want to do? Oh yeah, screwdriver. My lab is a mess. I need to clean that up. Okay, let's open it. So, oh, wow, this is tight. Oh, okay. Need a bigger one to not strip the screw. I'll use this flat. A karma was found dead. What? Yes, that works. Yeah, it's because this is the mounting point. It needs to be like really strong. At least it's like really heavy. So it's quite some metal here. This is completely out of metal. There is no plastic, as I can see that. Here, this part is plastic, this cover. That should be metal as well, yeah. Now, this was probably sealed. There is a seal at least, so it's probably water tight. No, it's not painted over. It's basically it's coming off. Okay, look at this. Nice. Okay. Do you want the link to the seller? I will drop it here for anyone who is interested in this particular device. It wasn't the fastest shipping, I must admit. I think I waited like a month, maybe 3 weeks. So I got it faster sometimes. Okay. Why doesn't it like store my language? This is the most annoying thing about AliExpress, that there's always like a random language. Where's English? Fuck. Not yeah. Bewahren. It was. Okay, here we go. They arrived, and let me check that. Link generator. Here. Boop. Here we go. This is the link for the linear actuator. Oh no, it's reading the link. Okay, linear motor. I will add it to my database. Snake, what? Yeah, it weighs really, it's heavy. This is probably 2 kilograms at least. Maybe, no, maybe it's, I can tell, this is 1 liter. So it shouldn't be 2 kilograms, it's maybe 1.5. Who knows? But it's really dense. Okay, here we go. This is the short, oh no. Scale out, okay. I don't know that I don't have a proper scale here, I think. I have only like a gold scale. Oh no. Slash linear dot, okay. Okay, so let's close that. I don't know. I will test it. I will. Okay, since I want to make it like a self-driving thing, I don't want it to be like super fast. So I can change the leverage on that. And this will be like one of the first prototypes with that kind of steering. So at the end, I know better what I really want, and especially. That's good. That's a good one. Fast enough for slow accidents. Okay. So I like it, Picasso. And it came with brackets, with mounting brackets, which is also nice. Okay, so what I'm working on, since I need money, YouTube isn't paying me anymore. I get like $250 a month. That's nothing. I can't pay rent from that. So I need another sponsored video. I didn't do sponsored videos for months now. And so PCB manufacturer. So I'm currently working on. I continued working again, since I had some fun with other stuff, on, get this away, on the S2 board again, and on the ADC. So you know this board, you remember? This one was assembled by Eisler. Oh, Christian, I wasn't able to schedule the stream because I just arrived at home half an hour prior to the stream, and then I basically set this up 15 minutes before the stream started. So YouTube was, to defend YouTube wasn't able to really give you like any hint on that. And but you can just check out every Wednesday, same time. Okay, same time. Now it's in the summer, bitluni summertime. It's 20 o'clock Central European time. So, look at that. That gave me even pins. So these are like aluminum pins, and here these things to secure the pins. So this is cool. One thing less to worry about, mounting brackets. And I have now 4 of these. Wasn't the cheapest thing to acquire, but now it's another standard part that I have in my lab for all the projects that need like super huge piston. Let me do it again. Yeah. It's cool. It's strong and fast. Yeah, same trash as every week. Yeah, so that's that. They finally arrived, and I'm really happy about this. Yep. But I might need another motor though, so one of the motors is causing some trouble, and buying another one is like 100 euros. I will wait until I buy the motor, until I got some like sponsor money, because it's like, wait, 100 euro if I buy it new, and they are hard to get, like the similar ones used. Okay, so this is this fact here. Oh, camera almost fell over. Okay, so back to this project, and what I was when I left for Berlin, I was working on this ad for my stupid shop here. Wait, no, oh here, now it's gone. But we need a fondue cam here. That's okay. So what I was working on, I can turn this on. Let me turn it on. Was to get a fast readout. So they say it's like a serial interface. It's not really SPI, even though they call it SPI, but I don't think it's SPI. At least I don't know the mode to read these ones. Let me tell you the part number that I'm using. So the ADCs. Oh yeah. So this is a board that has eight really fast ADCs. They can acquire, I think, 2 mega samples, up to 3 mega samples, and I have 8, and they have like a clock, a chip select, a clock, and a data pin. So I have like all of the chips have the same clock, same chip select, but each one has a different data line. So what I want to do is read all the values at the same time. I think we did some work on that already. I can show you what I achieved so far of the code. Why didn't... nobody is talking. Maybe I'm offline. So this is an S2 board. And what I tried is to just read the pins, the pin register, so I/O register, the first I/O register, all 32 pins at once, store them, next. That was my strategy, to read this and then give it some clock signals. I can show some code if you want to turn off. If you want to fall asleep already, I will show you some code. Where is code? Is this one? I have no clue. That's not the one. No. Let me find it. I just start Arduino. I have Arduino is loading. I need some more noms. Someone joined. Okay. Okay. So, I show you a simple example. I'm sorry. Sorry to hear that. So, this is my example for one pin. Basically the first ADC. We did this. I know, I can remember we did this. But basically, to give you a recap, I rewrote the code and changed, optimized stuff more and more and more and more to get the maximum speed that I can do without DMA and some I2S or whatever hardware peripheral. And basically, what I'm doing now is like, this is the sequence. We have 16 clock cycles that we can use 14. 14 is enough for that, I think. It's not necessary, but then you will fill like your word and you can push that away. And basically, clearing chip select. Hey Anna, did I miss you? Oh, Dave Odessa is also here. I missed some people. Okay, so it samples when chip select is high. So this is like not chip select. And when it's high, it's basically sampling and then like recording the sample. And then when it's low, with each cycle, the first one is always 0. And then each clock cycle is 1 bit that it pushes out on data, and it has like 12 bits. So on like 13 clock cycle, we already set chip select high, and we cycle more, so the ADC has time to acquire a new sample. And there are some like timings to have. Here, this is like on the clock cycle, since it's manual, these microseconds, which are 5 here, theoretical 5 microseconds, because you can do this precisely with delay microseconds. We have like 1, half a cycle low where nothing happens, and then we have quarter a cycle high, then we read in the middle of this high phase, and then another delay before we repeat and have that. So this is like an overview how this sampling works. This works definitively because we get output. Fake subs detected. We will scan and remove your fake subs. You will get a notification, or your channel will be flagged or something. Okay. So all this Arduino stuff has tons of overhead. What I continued is to what we did before already is to have implement a delay method that waits for a few clock cycles of the CPU of the ESP32, and we read like the register directly. We don't need like this overhead that's happening there. Also, we set and clear the pins. So what I discovered is 2 megasamples is really fast because the clock is like 48 megahertz. So this complete loop, like one cycle of this loop one loop 48 million times a second isn't possible even with the ESP. And what I did, I optimized the whole thing. This is my last code. I tried to get really everything you can get. I unrolled a complete loop, optimized like bit writes, because we have like only 12 bits that are valid and so on. And what I discovered at the end, we have now delay cycles. This is the method that waits. These are the writing set clock, and so we are using all the stuff and it's all like optimized, so inline. And what I discovered is the thing that, okay, so like writing the sample isn't the slowest part, because the ESP has enough cache to basically cache the samples and write them at some point where the CPU is busy with something else. So what I saw is basically changing like one bit of the output registers takes the most. I don't know how many cycles, it's really many cycles. So with this optimized loop, everyone visit the Embedded Hobbyist and subscribe to his channel. Okay. Or should we check him out right now? Okay, let me recap this first. So when I turn on the wave generator, I think that GH5 here. So we have a wave generation that's 40 kilohertz, a sine wave 40 kilohertz, and is it? No, it's not plugged in. So what I'm doing is I'm recording test successful. So I'm recording of this sample. Sample count is basically 1000 samples. Okay, I record 1000 samples with the fastest speed that is possible. So what I implemented here is like the cycles is basically, so our clock, it's specified in the data sheet that the clock cycle and the maximum deviation is like 40-60, like a ratio from low to high and so on. So basically, since we are writing the clock manually, we need to be sure that everything is timed precisely, and that's like the best I could do with direct register manipulation without any peripheral. And I was able to achieve how much? Let me check if we can serial plotter. Okay, here we go. So I am able to achieve around 5 megahertz clock is the highest I could achieve. 5 megahertz clock, it's like 340 kilosamples a second. And this works with like 32 pins at once, because I'm always recording like yes, we can hear you. So basically, I can do this in parallel. I can store like 340 kilohertz the samples. But I want more. So either I will end this episode of the video, like the one that I really want to release this week, since I need to move on with different project, the sub project. So either I do it until this point, which already is working. So this is already like a manual thing, but it's tasty. But what I wanted to do is like use a peripheral. Oh, really? That's cool. I'm doing a mess here. That is good, cool. Life, joy and pleasure will join you if you don't seek pain. What? No. Yeah, that's the way to go. You just need hardware once and then just reuse it for 1 million projects. Okay, so 340 kilohertz is already something. So we maybe can detect. Oh yeah, 340 is by coincidence. A kilohertz is speed of sound is 343 meters per second. So if we measure like audio feedback, one sample So one sample is basically a traveling distance of 1 millimeter. On this sampling rate that I am able to achieve, like with basic read write. And now I took a look. Can we generate the clock and the chip select, which always are looking the same? They're always the same. But we need to send this and then time our reading with this chip select and clock. Can I show it? Let me show it. I have recorded everything, so I will spoil you already. Okay, let me turn that off. That's probably no, that's my sub-testing. Oh yeah, here we go. I think, yeah, there you can see. Oh yeah, it's even 5.7 megahertz. So this is the clock, and you see it's already like out of spec at some points. You can see that. Let me move that window away. So this is the clock that I'm generating, the upper thing here. Wait, this one here. This is the clock signal, and this is the chip select. So we get like the sampling here. There is sampling happening, and yeah, and this is basically. I don't know if it right now. That doesn't do anything. Yeah, it's basically I need to like. Yeah. Much cleaner if you do it slow, but this is something like this is like the highest sampling rate that I was able to achieve, where the ADCs even wouldn't bug out. So I had I tried different ones where I wasn't able to read a proper sample. So it happens that if you are too far out of spec, it wouldn't do anything. But in this case, like the really short, we can see there are some here. I think here, yeah, this is like there is no like bit shifting happening here, because this is already the sampling phase. For the sampling phase, there is only specified that it needs like 15 nanos. 15 nanoseconds or something is needed to get the sample. So this needs to be 15 nanoseconds wide. So this is highly optimized already. And what I wanted to do is, we have the peripherals. Let's see, like the LED peripherals. Let me share that. This is the SPI. Okay, let me search it. Let's, okay. Whoops, this is LED control. Let's see. Okay. So usually you can go up to 80 megahertz. But then unfortunately, okay, so I could generate a clock that is fast enough. Like 40 megahertz would be okay for a sampling rate. Like we don't get like the full sampling rate, but 40 megahertz is already like really fast. So we could use like this clock basically, and 50% duty cycle will be perfect for sampling the ADC. So, and I tried to set this up, use the sample code, and then what you find out is Let me search that. What I found out is that the S2, here we go. What the this is butchered. So I can't use the S2, the let's control. I can't use it because it basically the highest that I was able to set the frequency of the PWM was I think 10 kilohertz or something. It's silly. So that wouldn't work. Then I thought, okay, let's do it like that. I need MS Paint. Where's... Yeah, no, nobody is listening. Okay, you moved on already. You people's not commenting anything. You're just listening. Okay. Okay. So what I thought about is, okay, we need like the clock, and then the chip select. It looks like that, no? This is what we would do there. So what I thought is, okay, let's do the following. Oh yeah, and we need to acquire. So usually we need, I think, was it low or high? But in the middle of that or at the falling edge is also okay. I believe. I think in the middle or falling or whatever, there's like one point, like where you can sample. Okay. You didn't get this? Okay, let me explain. Okay, so let me explain by showing it again. So I have this IC. Yeah, it's single core, and yeah, I don't use Wi-Fi there. I basically what I have to do is, since I'm building a different type of sonar, so maybe I should start all over again. So yeah, it's single core. That's why it's like, and it's cheap. Okay. I wanted to do the S2 because of the availability. So you can, if you want to like make a product, S2 is cheap and it's available. So what I want to do is I have like one transducer, which transmitter, which will just get a signal, which looks like that, a ping, like in Hunt for Red October, boo, and this will travel. This will travel and hit an object and bounce back, and then we have the array here of receivers, up to 16 at a time. Okay, and since you see, you get like a slight delay between the receivers and a phase shift. So basically what we did with the phase arrays, but reversed. So you have a different timing of this pulse coming in. Yeah, but this was like creating a beam that was basically targeting and just receiving the echo. So this was basically in reverse. These were creating a beam in that direction, and there was one receiver that basically receives if there is something, like if there is an echo. And this is now a different way around, since we can basically send one ping in all directions at the same time and receive from all directions all the echoes and analyze that, visualize them, okay? So it's way faster to do it like that, but you need to process quite a lot of recordings. So what we need is, we get like an input, that an analog input that's basically looking like that, from all these things at once. And since the transducers are working on 40 kilohertz, you can't use like audio for that anymore. Okay? So basically, like we calculated 340 kilohertz is 1 millimeter difference in travel time. So basically, to get a precise like analysis, the higher the precision or sampling rate in that case, the smaller the voxel size that you can analyze. So the more precise you can locate everything. So we get like a ton of signals with different delays, and we are able to, the calculation is really simple at the end. But we can see, okay, since it's delayed in that direction, like to explain it without any proper analysis, we can detect, oh yeah, okay. So we need the time progresses in this, so this is time, okay. So we know this echo is coming from the left. So like this skew. And so we need to record sample at a really fast sampling rate. There are different tricks. So if you look on Discord in the channel for the phase array, there's a researcher from Darmstadt. He uses a bunch of tricks to be able to use like 192 kilohertz sampling, and some analysis. So he converts like into frequency space, and then he explains that in the channel. I forgot already, but bunch of complicated math. Yeah, bunch of complicated stuff. And I thought, okay, why do complicated stuff if we can do this simple stuff that we can basically see already here, and not doing much math, and which everyone would be probably is able to understand, and then just use higher sampling rates. And since the ADCs, so analog digital converters, that I found that I'm using, they are really small. That's a SOT 23, I think, IC, and they support like 2 mega samples. But the problem is that we need the signal. So what we are doing is we are sending this clock signal, since we don't use many pins to read like the sample that yeah. So these ADCs, they communicate with a serial port, which basically is like SPI. So we have a chip select, which tells the IC, yes. So we have like eight. So here you can see, I can show it. I have more boards than that. Here. Oh. So this is the analog board. This is the input from the transducers. And I put like 4 on each side to have like the similar distance from the pins and not much noise. So there's just a straight line from the pin to the ADC. And the ADC, they don't have many pins. They have 6 pins. So, and I don't want to use more pins to transfer like the, in this case, 8-bit sample. I think this was 8-bit. To transfer it in parallel would take a lot of pins, and I can't do this for 8 times 2. Since I can connect to this one, I can connect like two of these ports. So I can use 16 transducers at the same time. Let's see. I don't know. I will just, I want like a scan, and then with a high rate. So, okay, you are limited to the speed of sound. Like you send one echo, and it returns. What's okay? One. I think you can do like probably 10 frames or even more per second. So you'll be able to see movement and so on. Basically like an ultrasonic device. But the speed is like, the frame rate wouldn't be like super high, but let's see what comes out. But now, oh yeah, this is a different one. This uses BGAs. Look at the send grains. These are BGA ADCs. This black things. 8-pin BGA. So back to the thing. Okay, so since the samples are 12-bit, no, this one is 12-bit. So and you need like 14 cycles to transfer the sample and another cycles to get the sample, to record the sample. So each of these blips here, which is basically telling the ADC to sample now and then transmit with each clock cycle 1 bit of the sample. So we need many more clocks than we get samples. So this clock rate here can go as high as 48 megahertz. And this is the sample rate, which can go to 2 megahertz. What I was able to achieve is, oh wait, you didn't see the mouse. Okay, this is up to 48, and this is 2 megahertz at the end, the max. And what I was able to achieve just with write operations that are highly optimized, this is basically the max that I was able to achieve, which is already quite high since we get like 10 samples. Yeah, but I don't know. I don't know for sure. So what is specified is that just CS high needs to be at least 15 nanoseconds, and it is implicitly given that you need to run the clock, since the deviation needs to be like, we are looking at the time of flight, because I generate the pulse, and then we record for a certain, we record a burst that we analyze and render. So we just need to get samples that reach like 10 meters back and forth. So we need to like see, okay, if we want to scan a room, we need probably 10 meters of reach. So we need 20 meters of samples. And the problem might be that we get too many samples. We can calculate this. Let's calculate what's 10 meters and 2 megahertz. So this was like, yeah, so anyways, what I want to do is This here is always the same. This is constant, and this is also constant. And what I need to do is to read the bits at a specific like position on this clock here, between these two. So if I'm like, if we like disassemble this whole communication, we need a stable clock. We need a stable chip select, which is basically based on this clock, which is a little bit shifted, so it needs to be like not really on the same position, but I think it wouldn't matter, so we can ship it. So basically we need a second pulse, like this could be like PWM. If we had like a fast LED control, we could generate these two signals from the same clock source, like CPU clock source. We could generate that and basically then sample, only read the samples, and that's all. So writing the signals takes the most. Yeah, something like that. Yeah. So if you can even see that. Look at the peak of the. Whenever it's high, it's reading. I think this was. Let me check that before I talk trash here. Fast optimized. Okay, set clock high, reading. Clear clock. No, wait. Oh, I don't know. Am I right? Wait. Yeah, this is already timed. But I know that like whenever I have something like yes, not on interrupt, but use a peripheral for that. We can read with I²S. Basically, we can use the generated signal, this clock. We can also use it as, okay, we could use I²S master mode and generate this clock also with I²S, but we can't generate this one here. So we can generate it if we do stereo. So let me tell you what we could try. I will just clear that. Doesn't. So all the possibilities that we need, that we can do. We can do. We can tell. I don't know if the I²S is capable of using different sample widths, or if we are locked to like 16-bit. But let's start with that. Let's assume we could use basically audio recording and let the CPU generate a clock. Generate a clock for that, which is basically the sample clock for I²S. And then we can use the channel signal to do the chip select. But that only works for 1 bit. We could do this, and this time will be wasted because we have a too long, we get a more precise maybe sample, but this is way too long, this high phase. We don't need like 16 clocks or 12 clocks, whatever. What's this? We don't need 16 clocks of sampling here. That would be a wasted time, but it would work. And since we want to record many channels at the same time, we have the LCD or camera modes. Yeah, but we want more than that. We need an analog signal, really, because we need to render the intensity. So it will be more sophisticated than just only like hitting a wall, but we want like a little bit more of that. And the analog thing basically allows us this phase shift and whatnot to calculate that. So I want all the goodness that we can get. So now we are not doing this serial thingy, but we can use the parallel mode. So this would be the CLK, and this will be the words. This is the serial mode of I2S. Okay, so this word, and then we have the data, which would basically come, and this is the master, so we are the master, and the data would basically come here in blah, 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 on, off, and so on, okay? We get the data here for one channel. I hate this. Let me remove that again, okay? So we get like some data here. Yeah, you draw it like the diamonds, don't you? Something like that, huh? Okay, here. This is data. Okay. So you get this here, and this is done. This is like high Z. No, wait. This is like some, and this is like high Z area. High Z, okay. And this comes in here. Okay, so this is like only valid data is during this phase, and this is basically a wasted word, but we can't do a different bit length for left and right channel. Yes, but the problem is we want to use cheap hardware that is available, no chip shortage, only S2. And I think it's still possible, even with the S2. So the other mode of the I2S is the parallel mode, which basically expects all the bits not in a serial manner, but in a parallel manner. And you can set up, let me clear that. So you can set up to 24 data lines. Not every, like, every configuration has the same speed, but you have basically, let's draw the oops. These are the data lines. And then you have your clock and you word data, word. So now you get all the data at once in this mode. So the clock is basically cycling like that. But also the word is cycling like that. The word and the clock are the same now. So unfortunately, you can't use the word clock anymore to emulate the chip select anymore, because we don't have that. But we still can use the clock or the word to generate the clock signal. We only need to generate the chip select in a different way. So this is only like theoretical content. I don't think that we will be able to solve it. But we could basically, we don't need, like, we can use a proper size here now of this, of the chip select. We just need to generate the signal somehow with a different peripheral than this one. What we can do is we can basically sample everything. Here, sample, like with this clock, we can sample all the data, store it away. Store it away. We could even store also this signal. So we store, let's say, 32 bits or 24 bits. We have like 16 bits that we have on our board here. So they're like two 8-bit connectors. And then if we just use 24-bit storage here, 24, we can add some more signals. We can add the clock here, we can add, or we can basically add this signal that we generate somewhere else. This chip select where it's generated somewhere else. So then when we recorded our burst, the echo time, it's stored somewhere here, but these are like individual bits of the samples. So it's not like we get a complete sample in one clock and then these are all sequential. We need to align, to know the precise alignment from this, we need a proper alignment from the chip select and the bits in the memory. And this would be the best to record this all at once, like in serial manner. So we know where the actual bits of our samples start and end, and then we are able to convert this to the samples. So that's the theory. So we get one sample as 0, as 1, and this will be channel, and we have more channels like that. Okay, dip, dip, dip. Oops. So now the theory, oops, camera tips over. Now the theory, or now I need to find what I thought about is, okay, why not use like a second I2S channel to generate this as an output of an audio output or something? You know what? S2 has only one channel. So we still are able to record at a fast rate, but we need to use a different peripheral to generate this chip select. Now, what are the options? We don't have fast LED control. We have only serial. We have UART. We have okay, but I to S is full duplex. I have no clue. Is it full duplex? Okay, let's read. Okay, so this stream will be boring because we won't code. I will just collect the ideas. So I will steal all your ideas. How does the duplex work with the I squared S? Yeah, but what does the duplex mean? Usually it means you can record and output at the same time, but I don't know how that works. I didn't see I do usually. Okay, so we could use it. Oh, look at this. Ah, sweet, isn't that? All modes. I think the problem is that they split the I squared S. PDMT, what is this? Okay. S2 only supports LCD and camera. Standard. Yeah, format. PDM, ADC. What? Full duplex. Oh yeah, but it's parallel. We have one parallel and I would use one serial for that. New channel. Yeah, but I think that would at 2 megahertz we get a ton on our data bus. I'm worried at this point if we are able to like do the fast speeds on that. Okay, let's check if the parallel mode, this is like LCD. They changed a lot. Yeah, this is a different thing here. They separated the stuff. I'm not sure if we can initialize it like in full duplex with camera and oh, okay, it has the two things. Maybe we should just take this example then. Wait, no. It's one at a time. Is it? No. This one here, camera board. What? Okay, noms are over. Oh, it's getting cold in here. Ah. It still isn't dark outside. We have the longest days of the year. Okay, I will get something, some jacket. Be right back. Okay, it was muted. Doesn't. Compatibility. Where's the link? Yeah. Wait. LCD. No, that's cam. Wait. So where are the examples? Did I miss a link to the examples? Ah, here we go. Yeah. Looks like LCD in it. Camera. But I think they are basically, they're using the same chips, but they are selecting the device with chip select. It's not running at the same time. Okay, let's try just full duplex. Oh wait, we have examples for that, for the not LCD examples. There is no. I'm wondering if you could do this full duplex mode where you use the same memory space and basically use the interrupts to process the audio. Yeah. Okay, we need to read the manual for that. How do we initialize? Oh, wait. Rejected. No, noch nicht. Okay, full duplex, there it is. Okay. Oh yeah, yeah. Let's try that. Okay, we need to check this structure. If that did I implement this init Genly? Oh yeah, battery standby mode. Yeah, that looks like my code, Genly. Oops, some quote. What is this? Simplex mode, okay. Oh yeah, we wanted to look for that clock GPIO config. This is the one. Okay, there is only one data pin. Now we need the parallel mode. So how does so okay, no, I think they split this, so we need to come on. Yeah, this is high level stuff. No, that's not what we need. I have not one power cut. Not a single one. On average once a year maybe. But that I think since we live here for 3 years we had it once. And that was like for... What? Okay, and this is basically like 1 second. That's I never experienced. Ah, okay. You need more solar projects. Peripherals camera. Where is the camera? Is there any camera peripheral? There is no camera peripheral. Okay, let's try again and see the API. Maybe there is some... clock. Standard mode. Okay, ice code S driver. New channel. Channel right. I don't see the parallel event data as a callback. Wait a second. Yeah, it's 6 minutes. Yeah, I think that they changed the API. I know this is like older code. They might have changed the API, and this might be deprecated, but so I did this before, but I did this on low level. I wanted to use the high level API to be compatible with different chips. But that's still might work. Okay, I think we won't do this because I'm really tired. Time passed by. This was the setup for a good thing that's coming up. Oh man, tomorrow will be long day. Another long day. Oh, 2 hours are too short, aren't they? But we saw a piston. I showed you the piston. The piston is great. And the motors, the one, the water cooled. This will be certainly good. Yeah, that's a good one. GPIO matrix out. Yeah. Yeah. Charles solved it the first probably. Yeah, this is low level. Oh, really? What? Really? Okay. I'm not able to concentrate anymore. Didn't I drop the code? Can't you generate from the code? Oh wait, I don't know if you have the last one. Okay. I will drop you the latest code. Why am I so tired right now? I can't concentrate anymore. Okay, peoples. Where's my camera? What is this? No, GH5. Boop. I think wait, I'm still looking for the code. Where's the code? Where's the code? Where is the code? Trying to find it. Here, this is function. Okay, here. I will post this. This code isn't even started on PC. Quote generator. Oh, this code takes so long. Okay, I can turn this off. By the way, maybe I will share that. By the way, oh, no battery remains. Sorry, next time. I'm using, okay, what I wanted to show is I'm using proper equipment. Look at this. Wait. Oh, I can't. Like, to not destroy, like, stuff like that. To not destroy my nice multimeter here. A multimeter oscilloscope. Wow. Damn, I'm wasted. Okay, peeps. I drop it in, what do we have? 1 day challenge? No, we have quotes. I don't know. Pretentious quotes. No, I will do it in 1 day challenge. I'll drop you the code. I don't see it. Where's the 1 day challenge? Here, okay. Latest code. Bam, here we go. More or less. Multimeter is able to measure other stuff that oscilloscope doesn't. Okay, everyone, thank you for joining. That have been 2 hours even though I should just go to sleep or take a shower. I wasn't even able to take a shower yet. Only a COVID test. It was negative so far. I will retest every day for 3 days now. And I see you next week. Have fun. Okay, here we go. Good night. Bye bye. Thanks for joining.